We're going to have a lot of fun with this guy right here, doing some application of the law of sines. So here we go. So I'm just going to read the problem, and then we're going to draw a diagram that would represent this. And the diagram is going to be gold for us, because wrong diagram means we'll get wrong mathematical work and all that. So it's very important that we interpret and we understand what the problem is saying, so we can draw the diagram that makes sense. So we're standing 40 feet, actually 40 meters from the base of a tree that is leaning 8 degrees from the vertical away from you. So this tree's chilling right now, kicked back and leaning over. And the angle of elevation from your feet to the top of the tree is 20 degrees and 50 minutes. And a little quick review real quick. We learned that in chapter 4 that 1 minute is 1/60th of a degree, and 1 second is 1/3600th of a degree. And we're going to use that here to interpret that. And we talked about how they used to do that historically many years ago. They used to represent the fractional part of angles in terms of minutes and degrees. So it's, I'm sorry, of minutes and in seconds. So we don't do that any longer, but I guess we just want to not forget how they did it there. I don't know. All right, so let's go ahead and let's see if we can draw a diagram that would represent this. So we are standing 40 meters from the base of a tree that is leaning 8 degrees from the vertical away from you. Okay, so let's go ahead and draw a little Billy. This will be us right here. Okay, so here he is. Hey, he's got like a frohawk going on right there. Ain't no laughing either. No laughing. Okay, and we got this tree in the house. Okay, now one thing that I want to point out though is that they say it's leaning 8 degrees from the vertical, meaning so that if there was a straight line like this, a vertical line, that means that the tree would be leaning this way 8 degrees right here. So watch, let me just draw my tree, and then I could kind of maybe show you what I mean by that. So my tree is going to kind of be leaning like this. Okay, so this is my tree right here. Okay, now check this out. So it's from the vertical, meaning if you had a north and south, if you had a vertical line right here, just like that, okay, they mean that this right here, bloop, that right there is 8 degrees. Okay, so when they say that, well, one, the tree's leaning away from us, and it says that it is leaning 8 degrees from the vertical. So starting from a vertical line, it's leaning away 8 degrees. Okay, so that's what that means there. All right, so we could also then, all right, so we have the distance from the base of the tree to us. So this is us right here. And it says the angle of elevation from your feet to the top of the tree is 20 degrees and 50 feet. So that means from here all the way up to here. There we go. All right. And actually, hopefully this isn't confusing you with this black line that's going vertical there. Maybe I'll delete that, and maybe I'll just put in like a dotted line, and that would kind of help a little bit. So I'm going to go right here and kind of just go like this. So really, it's not really part of it. It's just kind of there to show us where the 8 came from. Okay, so this is the diagram that we needed to come up with. And let's just go ahead and put in this degree right here. Elevation means that if I'm looking straight ahead, meaning if our eyes are at our feet, because it says from our feet, and then elevation means it's going up. So this right here would give us our 20 degrees and 15 feet. 15 feet. Okay. We need to find, actually, let's just go and see what we need to do here. Draw a triangle that represents the problem. Voila. And you can think of this as the side of our triangle right here. From here to there. I mean, like I have a tree going on right there, but really, we're not counting the leaves. Anything like that, just like that there, right? So it says draw a triangle that represents the problem. Woo! We got it. Show the known quantities on the triangle. So we kind of put all the stuff that we know. Well, actually, there's a few other things that we can put on here. Check this out. Well, if that's 8 degrees right here, then what is this right here? 90, right? Which then means that this whole thing right here, the whole angle, is 98 degrees. Because if this is 90, and then we have the 8, 90 plus 8 would give us 98 degrees. So I think that takes care of show the known quantities and use a variable to indicate the height of the tree. So we need to go ahead and we're just going to put an H right here then. Okay, because we want to find out how tall is the tree really, what's trying to creep right there. Okay, part B. Write an equation that's involving the unknown height of the tree. So if you actually want to find what is the height of the tree, then we're going to want to use our law of sines right now. So check this out. Oh, and you are saying 40 feet, so that means this should be 40 right here. Okay, that makes sense. 40 meters. So if this is 20 degrees and 15 feet, or 15 minutes, this really doesn't make much sense in the context of degrees, right? So let's actually change this. Okay, so 20 degrees and 15 minutes is the same thing. If you want to actually get the actual degree, would be 20 degrees plus, again, look right here, for every one degree, okay, for 1 degree is going to be 1/60th of that. So that means I have to take a 60th of that. So 15 over 60, okay? And again, this is going to be an approximation because the decimal, okay? But this is going to give us 20.83, okay? So I can replace this right here with 20.83, which means I can find this missing angle right here, which is 180 minus, let's see, plus, or actually minus, I'm going to be subtracting right now. So we're going to subtract these two quantities, right? So 20.83 plus 98 degrees. So if we do all that, then that means that this angle is going to be 61.17 degrees. Okay, so that's what that's going to be right here. Okay, so hopefully this makes sense now that we can put this all together to find H by doing our law of sines. Okay, let's go ahead and do it then. We can do sine of this guy, sine of 61.17, all over the opposite of that, which is 40. And that's equal to sine of 20 degrees and 15 minutes. Oops, I should put a minute right there. Now you can just replace that with 20.83, but in my calculator, I want it to be as accurate as possible, so I'm not going to put my approximate answer rate, not 20.83. In the calculator, I'm going to do sine, in parentheses, 20 plus 15 over 60, because we want to get the most precise answer possible without using all these rounded answers. I don't think that makes sense. That we don't want to just use rounded answers everywhere. We want to use precise answers as much as possible, all over H. Okay, so let's go ahead and cross multiply. So H times sine of 61.17 is equal to 40 times sine of 20 degrees and 15 minutes right there. So our answer then, let's divide. So it's going to be 40 times sine, 20 degrees, 15 minutes, all over sine of 61.17. Okay, so this one right here, get your calculator out and see if you get this answer that I'm getting right now, because it's the small stuff that's gonna hurt you on the points if you get these things wrong. So you should get 16.2. when you solve right there. And I guess we're in meters in, so this is 16.2 meters.